Hey guys, this is Mr. Gron, and this is the lesson on section 6.9, curve fitting with polynomial models. So essentially what we're doing today, if you think back to Algebra 2 when we did linear regression models, meaning we took a scatter plot of data, and we figured out a line of best fit that went through that data, we're essentially doing the same thing, only now we're going to be looking at situations where the data, the scatter plot, would not be linearly correlated, but it might be a higher degree polynomial that best fits that data. So to start, we are going to just review a little bit about degree. So if you remember the names of polynomials based off their degree, for a first degree, it's a linear, second degree is our quadratic, third degree cubic, and so on and so forth. So we're going to refer back to some of these vocab terms from earlier in chapter 6 today. All right, so it's just a quick review of some vocab from earlier in chapter 6, naming polynomials by their degrees. First is linear, second is quadratic, and so on, just like we did in 6.1. One of the things that we can tell about a graph based on its degree is the maximum number of curves that graph can have. The maximum number of curves is going to be one less than the degree. So for a linear function with a degree of 1, that means that there are 0 curves. And if we think about what a linear function looks like, if this is our xy axis, a linear function is a straight line and 0 curves there. For a quadratic, the degree is 2. That means that the maximum number of curves is 1 curve. And if we think about what a quadratic function looks like, right? Here's our xy axis. A parabola looks like this. So it has 1 curve. Now it's important to point out that a curve in a polynomial, what we call a curve, what we consider a curve, isn't necessarily just a point where the line sort of makes an arc, right, where it's not quite straight. It's where the graph changes direction, meaning that if we look at this quadratic, if I read it from left to right, it's descending here. It's getting lower and lower, and then it reaches a minimum point, and then it starts going back up. We always read these graphs from left to right. So we would say that it's decreasing until it gets to the vertex, and then it's increasing. That change in direction where it's going from increasing to decreasing or decreasing to increasing, that is what we consider a curve. All right, so a cubic, then, a degree of 3 that has a maximum of 2 curves. And so if we think about what a cubic looks like, one example of a cubic, it might look something like this, where it's got a curve here at this relative maximum and a curve here at the relative minimum. Now, another thing to point out here is that this is the maximum number of curves. So a cubic, for example, if we look at a really basic one, like y equals x cubed, with no x squared term, no linear, anything like that, it's going to look like this. And that actually has 0 curves. Now you might think, well, there's a curve in the line right here, and there's a curve in the line right here, but there's no change in direction anywhere. So this doesn't count as a curve, and this part doesn't count as a curve. It only counts as a curve if it changes direction, from going up to going down as you're moving across the graph.